and welcome back to Project Leah. I'm still Xavier Mendoza, and today I'll be talking to you about the ultrasonic sensor. So before this lesson, we've talked about LEDs and buzzers. Those components have only had 2 pins. However, now this ultrasonic sensor is going to use 3 pins. So referring back to those LED and that buzzer, there was a ground and a signal, which we were completing that circuit through our Arduino and giving it power. However, now with these 3 pin components, there will be a ground, a 5-volt, and a signal pin. So basically, our component is being powered on and waiting for our signal from our Arduino, which we will program later, to be activated. So it's basically always on standby. So why do we need these components? Well, a better question is, how do we make these robots feel? Or more importantly, the Arduino feel? So an Arduino is just a microcontroller. It has no sensors, it cannot feel touch or anything. So with this ultrasonic sensor specifically, we can measure distance. So that way we can basically give it eyes. So the way this ultrasonic sensor works is over here on the right side will be a transmitting signal, and on the left side there will be a receiving signal. So essentially in the programming, you'll be transmitting a high-pitched signal that we do not hear, just like bats, and then it'll be bouncing off, say, my hand or a wall, and then bouncing back to that receiving pin. So if you think about it, it's going like this and coming back. In our programming, we can basically harness echolocation, such as bats, to pinpoint our specific location. Now we're going to get into wiring this bad boy. In order to safely do so, we're going to disconnect our Arduino from our computer and work on our breadboard without having any power, so that way we don't damage or fry our Arduino. So let's look at the component. So the ultrasonic sensor has 3 pins, just as mentioned before. So going from left to right, starting on the left, that is a signal pin. The middle pin is a 5 volts, and that far right pin is a ground. So if you know how to use a breadboard, or if you don't, you can refer back to our breadboard tutorial. So we can literally place this wherever we want on our breadboard. So we're going to say here, and then now we're going to hook it up. So you're going to grab 3 wires because we have 3 pins. We're going to use the black one for ground, the red one for 5 volts, and the white for a signal pin. So we're going to start with the ground. Our ground is located on the way bottom in its orientation right here. So we're in line with our ground pin, and now we can jump that ground to our Arduino pin, just as such, just like that. Alright, so now we're going to grab that 5-volt pin, which is our middle pin. There you go, and connect that to our Arduino, just like that. And lastly, we're going to connect our signal pin to our Arduino, and we can literally place this whatever digital pin we're going to call in our program. For this example, we'll do pin 7. Alright, now we have hooked up our ultrasonic sensor to our breadboard and to our Arduino. So now we can open up the Arduino IDE to start programming. We're going to let that boot up, and while that's doing that, we can actually connect our Arduino to our computer. Alright, it's going to open up the last thing you had open, and we're going to go under File, Examples, Sensors, down to Ping. Click on that, close our last thing we had open, maximize this. Alright, so we're going to check to see if our Arduino is connected. We can go to Tools, down to Port, select our Arduino Uno. Alright, so looking at this example, so somebody made this example because the ultrasonic sensor is readily available and out there on the market. So in order for us to use it as a consumer, they're going to provide a code for us. So looking at the code, we're gonna look at the top right here. Constant initialize ping pin equals 7. So it's basically, as you guys know before, it's just saying that this variable ping pin is connected to our pin 7. In our void setup, we're going to start a serial.begin 9600, and this is basically just like you guys are looking at a computer screen. This is basically an Arduino computer screen. So we have to start it so that we can use it later. Going down to our void loop. Long, duration, inches, centimeters. Those are just variables that we'll use later. Now over here, this is where the magic happens for our ultrasonic sensor. So this section is basically outputting a signal. So starting from here, this line declares that our ping pin, which is equal to 7, is going to be an output. So the next thing we want to do is make it a low, just to make sure that that we get a good clean signal to send. We're going to do this very fast, delay microseconds, which is basically 10 to the negative 6. And then now we can turn on our ping pin high for 5 microseconds. That way we're going to emit that sound, and then we're going to turn it off. Alright, so we already sent our sound into the atmosphere, and then now we have to retrieve that through our component. So very fast, the Arduino is going to make that same ping pin, pin 7, an input, so that way we can catch our echo we already sent out. So it's going to do that right there, and then now we're just going to give whatever we sent out, we're going to make it come in through our door. So it's an input and it goes high. So if you think about a door, high means that the door is open, so we want to leave the door open so that our echo can come in through our input. So now we're just changing that to this variable here, which is duration, and we're going to use that later. And so we're going to look at just inches right here. So inches, we're going to do some math to convert the time into a distance. So this right here matches up directly to this sub loop down here. As you can see, literally named the same and uses that duration that we already stored. So coming down here, we're going to read this comment here. So according to Parallax's datasheet for the ping, there are 73.74 microseconds per inch. This gives a distance traveled by the ping. So we're going to do some math. So we have microseconds we already have calculated. These two match up right there, which is basically our duration, which is right there. And so since we already have time, we can use basically math that we already know in our world, because we know how fast sound travels, and 74. So these two match up. They basically just rounded that, and then they're going to divide by 2. So we divide by 2 because the sound has to travel to an object and then bounce off and come back to our component. So if we divide by 2, we can determine that that wall is at that halfway distance. It's going to return this back up to here, and so now we have that stored into inches. And so now we can print that to our serial monitor right here, and then just give it a generic, in these quotations, the inches. And then that's the explanation of the code. It's going to delay every 1/10 of a second here, and then just repeat this in a loop. Just keep doing this. So we're going to upload this to our board. Click upload, compiling sketch, uploading, and now it's uploaded. So we're going to open up our serial monitor, which is in the top right corner. We're going to click on it, and it's going to display our inches. So right now, I have the Arduino box in front of it, and taking it away, bringing it closer, taking it away, and it actively shows in our serial monitor what the Arduino is inputting to that ping pin. This concludes our ultrasonic tutorial. Check back in with Project Leah.